Okay guys, now let's do a bit in depth the graphical studies. Alright, now we saw that in one case the SHM started from mean position, in another case we saw that it started from extreme position. Alright, so we derived those equations and graphs. So I've just put them one below the other to understand better. So basically this is the situation. So we know that whenever it is moving here at extreme position, the phase changes by pi by 2. Again when it comes back here, again another pi by 2. Again when it goes there, another pi by 2. And then again when it comes back, another pi by 2. This way it gets back. When it comes back for one period, the phase comes to 2 pi. Alright, okay. Now starting from mean position, this was the equation, this was the curve, one below the other. So better to understand. And for velocity, we already derived, this was the curve, cos curve it was. And then again for acceleration was sine curve. All right, so similarly here when we talk about starting from extreme position, it is a cos omega t displacement. All right, so it's a cos curve, this is a sine curve, and this is again a cos curve, negative cos curve, and this is negative sine curve, and this is positive cos curve. All right, positive cos curve, negative cos curve. Now, so this is the situation. Now let us try to compare it a bit. All right, now for comparison, now when time is t is equal to 0, all right, when time t is equal to 0, when time t is equal to 0, it's at this position. So here when we are talking in terms of 0, so a sine omega t, assume this to be theta. Why? Because we know theta over t is omega. So theta is omega t. So this is theta, this is theta, this is omega t. All omega t is assumed to be theta. Alright, so a sine theta is our formula for x. So at time t is equal to 0, theta is equal to 0, sine 0 is 0, so x is equal to 0. So that's why x is equal to 0. That's what we are doing actually. We are starting it from mean position. So obviously x has to be 0. Then velocity formula is a omega. Now it is cos 0. Cos 0 is 1. So velocity is a omega. So a omega. And acceleration, when we come back again, that's a sine curve. So sine 0 is 0. So that also becomes 0. So this becomes 0. Now here itself we get that 36 ka akada thing. Now here velocity is maximum. Acceleration is 0. So opposite, right? Okay. Now let us move to T4. Now we know, I hope it's all clear why we call it as T4, because this entire thing is T. So these are divided into 4 parts. So this becomes T4. So T4 over here, when we are talking in terms of a sine omega t or theta, I had already explained that this is pi by 2. All right. So when it goes to extreme position, it covers, phase gets the value of pi by 2. So the angle covered is theta. So it is pi by 2. And so let's substitute pi by 2 everywhere. So this sine 90 we know is 1. So t by 4, pi by 2. So 1. So displacement is a, and it is cos. Now cos 90 is 0. So velocity is 0. Right? Velocity is 0. And then again this is sine. So this becomes 1. So this is minus a omega square. Alright. So when we check out this, so again here also we get that story, 36 wala story, clear. 36, 36 wala story, 36 ka akada. So here velocity is 0 and acceleration is maximum. Alright, so at this point velocity is 0. We know, right? It stops here. So velocity is 0. So acceleration has to be maximum. So proved by graph by substitution. Similarly, if you go ahead, you will find that you will get all these values. And let's understand what's the situation in cos curve, or rather when the SHM starts from extreme position. All right, let's get into it. All right, when is it? It is at extreme position. The time period t is 0, phase is also 0, omega t is also 0. So when it starts, time is 0. Capital T is also 0, that is time period is also 0, and phase is also 0. Omega into t is 0, so it is also 0. Alright. Now, it moves from here to here, from extreme to mean position. So, as per time period, it is t by 4. and as per phase it is pi by 2. Alright, so that is what we saw here. It is t by 4 and pi by 2. Then again when it moves from here to here, it is yet another t by 4 plus t by 4 is t by 2 in terms of time period. Pi by 2 plus pi by 2 is pi. So when it moves to another extreme position, then it is t by 2 in terms of time period, and by phase it has moved by pi. Then again when it comes back from there to here, it has covered another pi by 2. So pi by 2 plus pi by 2 plus yet another pi by 2. So it is 3 pi by 2, and by time period it is t by 4, t by 4, t by 4, 3 t by 4. So 3 t by 4 and 3 pi by 2. Then when it comes back again to its original position, that is it has covered one period. So t by 4, t by 4, t by 4, t by 4. So 4 t by 4, that is one period t. Alright, and phase wise pi by 2, pi by 2, pi by 2, pi by 2, 4 pi by 2. So that is 2 pi in terms of phase. Okay, why did I do all these things in detail? So that it becomes very easy for you now to convert those angle in terms of cos and sine and cos. So we have jotted down, we understood this connection. Now let us start from here. So when it is here, what is the displacement? Displacement when it is here, now we know it is cos 0. Cos 0 is 1. Since cos 0 is 1, so this gets the value of A, obviously A. Alright, so it is the amplitude. Alright, A. Now it gets the value of A. Alright, then so it gets the value of A. But what about velocity? Velocity is minus A omega, and it is sine. So it would be sine 0. Sine 0 we know is 0. So this value becomes 0. So velocity becomes 0. Velocity becomes 0. Then in case of acceleration, it is again cos. So cos 0 is 1. So it gets the value of minus A omega square, gets the value of minus omega square. And mind you, this is positive A. So it's starting from here. This is 0. So in case of velocity, it is starting from here. And this is minus A omega square. So it starts from here, minus omega square. So I hope this is all clear. Then what happens in case of t by 4, pi by 2? So obviously now we are talking in terms of cos 90. Cos 90 we know is 0. So displacement cos 90 is 0. So it comes back here. Alright, so when it comes back here, displacement obviously is 0 because it has come back to mean position. So that is what we say here. That's what we see here. Displacement is 0. Then when we come to velocity, it is sine 90 pi by 2. Sine 90 is 1. So it is minus A omega. Velocity is minus A omega. Velocity is minus A omega. So the velocity over here is minus omega. Displacement is 0. Velocity is minus A omega. Now let's check out whether that 36 ka ankada which I have been talking about, is it okay? Alright. So now we are talking about pi by 2, but of cos. So cos pi by 2 we know is cos 90, and we know that it's 0. So this becomes 0. So that's what we saw here. Alright, so maximum is the velocity and 0 is the acceleration. Alright, so 36 ka ankada proved. Similarly, you can also see for these values. You will check out and you will find all those values. So everywhere we'll find that, see, velocity here is this, acceleration is this. When velocity is this, acceleration is this. Then again when velocity at 3t by 4 is this, acceleration this. So that is what is 36 ka ankada. Always keep in mind whenever it is at extreme, if you are starting from extreme position, displacement is A. Why? Because we are starting from here, it is from extreme position. So the displacement is A, but velocity is 0 because we are just starting. So always keep in mind whenever it is at extreme positions, the velocity is obviously has to be 0 because it is returning back from there. So once you keep in mind that velocity is 0 over here, we also know that the acceleration is maximum over there. Alright, and if velocity is 0 here, we know that, then obviously velocity has to be maximum over here in mean position. And if velocity is maximum over here, then acceleration has to be 0 over there. Alright, so keep it in mind that ways to avoid any confusion about velocity and acceleration and 36 ka aakada. Alright, I hope this would help you out in sorting out your numericals based on this. Alright.